What makes a volcano blow its top? Time to explore the fiery underworld and find out. Deep inside the Earth, there's a bubbling cauldron called the magma chamber, or think of it like a giant pressure cooker filled with molten rock. As magma heats up, gases expand, building up intense pressure. But what exactly is magma, and where does it come from? Magma is a mixture of molten or semi-molten rock, volatiles and solids that is found beneath the surface of the Earth. The formation of magma is a complex process that involves the melting of the Earth's mantle and crust due to various factors such as temperature, pressure, and the presence of water. When rocks in the mantle melt, they form magma, which is less dense than the surrounding solid rock. This causes the magma to rise towards the Earth's surface. As it ascends, it can accumulate in large reservoirs known as magma chambers. These chambers can be found at various depths within the Earth's crust and can vary in size from a few kilometers to several tens of kilometers in diameter. The composition of magma can also vary depending on the types of rocks that have melted and the conditions under which the melting occurred. Some magmas are rich in silica, making them more viscous, while others have lower silica content and are more fluid. The presence of dissolved gases, such as water vapor, carbon dioxide, and sulfur dioxide, also plays a crucial role in the behavior of magma. These gases are trapped within the magma under high pressure, and as the magma rises, the pressure decreases, allowing the gases to expand and form bubbles. This process is similar to what happens when you open a bottle of carbonated soda. The dissolved carbon dioxide in the soda is under pressure, and when the bottle is opened, the pressure is released, causing the gas to form bubbles and escape. In the case of magma, the expanding gases increase the pressure within the magma chamber, and if the pressure becomes too great, it can cause the surrounding rock to fracture, creating pathways for the magma to escape to the surface. This is when we witness the dramatic and often destructive phenomenon known as a volcanic eruption. When the pressure becomes too much, BAM! The magma shoots up through cracks in the Earth's crust. That's when we see an eruption. The type of eruption can vary depending on the characteristics of the magma and the structure of the volcano. Some eruptions are explosive, sending ash, gas, and volcanic rock high into the atmosphere, while others are effusive, with lava flowing steadily from the vent. Explosive eruptions are typically associated with magma that has a high silica content, making it more viscous and trapping more gas. When the pressure is released, the gas expands rapidly, causing a violent explosion. Effusive eruptions, on the other hand, involve magma with lower silica content, which is more fluid and allows gas to escape more easily. This results in a steady flow of lava rather than an explosive event. The lava that emerges during an eruption can take on different forms depending on its composition and the conditions under which it cools. Pahoho lava, for example, is smooth and ropey, while A'a lava is rough and jagged. The temperature of the lava can also influence its appearance, with hotter lava being more fluid and cooler lava being more viscous. As the lava flows away from the vent, it begins to cool and solidify, forming new rock. This process can create a variety of volcanic landforms, such as lava plateaus, shield volcanoes, and lava domes. The ash and volcanic rock ejected during an explosive eruption can also have significant impacts on the surrounding environment. Ash can blanket the landscape, smothering vegetation and contaminating water sources. The fine particles can also be carried by the wind, affecting areas far from the eruption site. In addition to the immediate impacts, volcanic eruptions can have long-term effects on the climate. The ash and gases released into the atmosphere can reflect sunlight, leading to a temporary cooling of the Earth's surface. This phenomenon, known as volcanic winter, can disrupt weather patterns and affect agricultural production. One of the most famous examples of this is the eruption of Mount Eta in 1815, which led to the Year Without a Summer in 1816. The eruption caused global temperatures to drop, resulting in crop failures and food shortages in many parts of the world. Despite their destructive potential, volcanic eruptions also play a crucial role in shaping the Earth's surface and creating new land. The Hawaiian Islands, for example, were formed by volcanic activity, and new islands continue to emerge as lava flows into the ocean and solidifies. Volcanic eruptions can also create fertile soil as the ash and rock break down over time, releasing nutrients that support plant growth. This is why many volcanic regions, such as the slopes of Mount Vesuvius in Italy, are known for their rich agricultural land. In addition to their geological and environmental significance, volcanoes have also played a prominent role in human culture and mythology. Many ancient civilizations revered volcanoes as powerful deities, and their eruptions were often seen as signs of divine wrath or favor. The ancient Romans, for example, believed that the god Vulcan, the god of fire and metalworking, resided beneath Mount Etna in Sicily. In Hawaiian mythology, the goddess Pele is said to live in the Kilauea volcano, and her fiery temper is believed to be responsible for the frequent eruptions. Today, scientists continue to study volcanoes to better understand their behavior and mitigate the risks they pose to human populations. Advances in technology have allowed researchers to monitor volcanic activity more closely, using tools such as seismometers, gas analyzers, and satellite imagery. By studying the signs of an impending eruption, such as increased seismic activity, changes in gas emissions, and ground deformation, scientists can provide early warnings and help communities prepare for potential eruptions. Despite these advances, predicting volcanic eruptions remains a challenging task, as each volcano has its own unique characteristics and behavior. Some volcanoes, like Mount St. Helens in the United States, give clear warning signs before erupting, while others, like Mount Eta in Japan, can erupt with little or no warning. This unpredictability underscores the importance of ongoing research and monitoring to improve our understanding of these powerful natural phenomena. So, next time you see a volcano, remember the fiery secrets lurking beneath. Stay curious, science enthusiasts. The study of volcanoes, known as volcanology, is a fascinating field that combines elements of geology, chemistry, physics, and environmental science. Volcanologists work in a variety of settings, from remote field sites to high-tech laboratories, to unravel the mysteries of volcanic activity. They collect samples of lava, ash, and gas to analyze their composition and understand the processes that drive eruptions. They also use computer models to simulate volcanic behavior and predict the potential impacts of future eruptions. In addition to their scientific research, volcanologists play a crucial role in public education and outreach. They work with government agencies, emergency responders, and local communities to develop hazard maps, evacuation plans, and other strategies to reduce the risks associated with volcanic eruptions. By sharing their knowledge and expertise, they help to build resilience and ensure that people are better prepared to respond to volcanic emergencies. The work of volcanologists is not without its challenges and dangers. Fieldwork often involves traveling to remote and hazardous locations where they must contend with difficult terrain, extreme weather conditions, and the constant threat of volcanic activity. Despite these risks, many volcanologists are driven by a deep passion for their work and a desire to contribute to our understanding of the natural world. Their efforts have led to significant advances in our knowledge of volcanoes and have helped to save lives and protect communities around the world. As we continue to explore the fiery underworld of volcanoes, we are reminded of the incredible power and beauty of these natural wonders. They are a testament to the dynamic and ever-changing nature of our planet, and they serve as a powerful reminder of the forces that shape our world. Whether you are a scientist, a student, or simply a curious observer, there is always something new to learn and discover about volcanoes. So stay curious and keep exploring the fascinating world of volcanology, curious science enthusiasts.